In this video, we look at this MIT integration B challenge question. This is the integral of the square roots. These are nested square roots of some expressions. So whenever you have this kind of integral, you can just start off by letting y to be equal to the integrand, or letting any variable of your choice. Here, y to be equal to the integrand. So the integrand here is the square root of x plus 1 over the square root of x plus 1 over the square root of x plus da 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 da. Yeah. So you let y to be equal to the integrand, the whole integrand. Then you can express y in terms of y and x. So y here is going to be the square root of x plus 1 over. So this one is the same as y because this is an infinite sum. This is the same as y, right? So y can be expressed as the square root of x plus 1 over y because this is an infinite sum, right? So 1 over y. So after this, then you can take the square on both sides. Taking the square on both sides, you have y squared to be equal to x plus 1 over y. Try to isolate x. So x is going to be y squared minus 1 over y. Then you differentiate x with respect to y, dx dy. That is going to be 2y minus 1 over y is negative 1 over y squared. So this is 2y plus 1 over y squared. So that implies that dx is 2y plus 1 over y squared, all this one dy. Sorry. So we have an expression for dx in terms of the new variable y, and this is y, our integrand. Now next is to find the change in limits, right? X is the original variable, so we now have to find the limits for y. The lower limit of x is 0, right? So we are going to use this expression. So this x in terms of y, right? So when x is 0, that is plugging in 0 here, and this is equals to y squared minus 1 over y. So what value of y here will lead to 0 in the left hand side? The only value that you can think of here is 1, right? When y is equals to 1. When y is equals to 1, you have y squared, which is 1 squared minus 1 over 1, which is 0. So when x is 0, y is going to be equal to 1. I'm sorry. What about the upper limit? The upper limit for x is 7 over 2. So you plug it here. So we have 7 over 2 to be equal to y squared minus 1 over y, right? What value of y will lead to 7 over 2 in the left hand side? So this one, let's try to simplify this one. So we can multiply by the LCM, which is 2y. So we have 7y minus, which is equals to 2y cubed minus 2. That is multiplying by the LCM. And then we have 2y cubed minus 7y minus 2 to be equal to 0. So what would be the value of y here that will make the right hand side here equal to 0? So when y here is equals to 2, we have 2 times 2 to the third minus 7 times 2 minus 2. This one is going to give you 16 minus 14 minus 2, and that is equal to 0, right? So y here is equals to 2. So when x is equals to 7 over 2, the upper limit, y is going to be 2, and that is the upper limit for y. So y will run from 1 to 2. And after doing this, the integral is now very easy. So the integral I is going to be the integral from 1 to 2. Those are the limits of y. From 1 to 2 of y times dx. If you look at our integral, this is y, that is the integrand, and dx. dx is this expression, which is 2y plus 1 over y squared, all this one dy. So this is the integral from 1 to 2 of 2y squared plus 1 over y. That is multiplying in with y and dy. So our integral is, we are now integrating, this is 2 over 3 y to the third plus the ln of y. The integral from 1 to 2. Plug in your limits of integration, do that 2 over 3 2 to the third plus ln of 2. This is the upper limit minus the lower limit, 2 over 3, 1 to the third plus ln of 1. So I is 2, x to the power 3 is 8, so this is 16 over 3 plus ln of 2 minus 2 over 3 minus ln of 1 is 0. So this one simplifies to 14 over 3 plus ln of 2, right? Because this and this will sum to 14 over 3. So 14 over 3 plus ln of 2. That is the answer to this integral. So if we integrate this MIT integration B challenge question, that is going to lead to 14 over 3 plus ln of 2. So this one, ladies and gentlemen, is the answer to this beautiful integral. So these are very easy integrals. You just let a variable of your choice to be equal to the integrand, and then you try to find an expression for dx in terms of the new variable. When you change the limits, everything becomes trivial, and then the integral can just be solved under 30 seconds. So that's just how I can solve this question. If you have any method, a better way of solving this one, leave the comment in the comment section and let me know what you think. Anyway, thank you so much for watching this video, and I'll see you in the next one. Bye bye.